All right, so we talked about hypothesis testing, what it is. Now we're going to get into the nitty-gritty details. So in order to make this work, we have some traditional views, traditional ideas of what hypothesis testing is all about. And so we start with describing our basic assumption, which is the null hypothesis. The null hypothesis is our standard. We set a standard and we say assume this to be true. So the null hypothesis is going to have an equals sign in it. And so it's an H with a subscript 0. Null hypothesis, which is saying to us this is our assumption. It can be either about the mean or about a proportion or about a standard deviation, right? Those are the three things we've been working with here. And then we have the question of what is it that we're trying to prove? It's very important to understand what we're trying to prove is called the alternative hypothesis. We cannot prove the null hypothesis. We cannot ever prove from a sample that we have something equal to a number. Right? Like we said, you can't do that. A sample is not accurate, so you cannot prove equality. But what we can do, this is the power of hypothesis testing, is that we can prove a difference. We can say, with a certain amount of confidence, the population measurement is either greater than or less than the number, some kind of standard number that's been set for us. Now, it's generally, when we're talking about these things, we're talking about alternative hypothesis as being different from the null hypothesis. Then that means we're looking at the tails. If we're looking for the sample as being higher than a certain number, that would be a right tail. If it's lower than a certain number, that would be a left tail. And it is possible sometimes, if we don't know what we're doing as far as either less than or greater than, we'll say it's two-tailed. It's a two-tailed test. I don't like two-tailed tests. I'm strange compared to other teachers, maybe, but I just don't like them. Because if we have the sample information, then we know something about what direction we're going. So what I give you will be one-tailed tests. Now, of course, when we say we're going to do a test, then we can adjust how confident we want to be in it, just like with confidence intervals, so that we can say, all right, I'm going to pick alpha, my chance of being wrong, and most of the time it's 5%, 0.05, but we pick that. Right? And so then we have the tail. If you have the distribution and then you have the tail and it's got an alpha in it, that place out there, that's called the rejection region or the critical region. Okay? So this is what we're saying, is that if the sample comes out to be in that place out there, in that tail, then we've found the place. We've found the difference. It is significantly different if it's out there in the tail, if it's in that rejection region. And so then that's how we set this up. We're going to set up the hypotheses. We're going to be trying to prove the alternative. We're going to be looking for where the tail is. And then we're going to use some kind of a equation or formula to say, all right, is it out there? Is it in that tail? And then once we get it out there, if it's out there, then we say we reject the null hypothesis. That's the goal. We want to reject the null hypothesis because that means we've proven something. we prove that there is a difference. Well then, okay, this is where a lot of people have trouble, all right? If you do not reject the null hypothesis, you have not proven anything. So we have two alternative choices when we get down to the end. Either we reject the null hypothesis, or we do not make a decision. We can never prove that equal sign. We can never prove that something is the same as a certain standard. So either we prove it's different, we reject the null hypothesis, or no decision. Those are the two possible options. So I'll come back and talk about more. But that is the idea of the main steps for hypothesis testing.